A few students had emailed me questions about some of the homework problems. I have them listed right there, so I just wanted to go over them to make sure everybody was clear on them. So first, on page 479, numbers 70 and 72, and I will actually point out, I did the same thing in my seated class. Some of the properties that are listed in your book, I deliberately didn't mention in, say, sections 4.1 and 4.2, because they are easier to see once you get to graphing, which we get to in 4.5. So I gave you some problems so you could see the definitions and maybe algebraically work with them a little, but ultimately they make more sense when you look at them graphically, similar to how we did things in 171. So yes, I am aware that some of these properties I didn't mention, they're listed in your book, but they make more sense when you work on the actual graphing properties. But number 70, we want to simplify secant of t plus 2 pi minus secant of negative t. Okay, and there's really two things here. One, secant is reciprocal of cosine, and we know, thinking about the unit circle, cosine repeats every 2 pi. Same with sine, every 2 pi the cycle repeats, which means they're what's called 2 pi periodic, or they have period 2 pi, or they repeat every 2 pi or every 360 degrees. What that means is secant is reciprocal of cosine, so it'll have the same properties. Secant of t plus 2 pi is the exact same as secant of t, because if, say, this is my angle t right here, if I add 2 pi to it, I go all the way around the circle and I end up at the exact same point. So I get the same secant value, which really means secant of t plus 2 pi is just secant of t. But now, we'll see a lot of times when we're taking trig functions of negative angles, and you can certainly do that, but there's also even and odd properties, if you remember them from 171. An even function, f of x equals f of negative x. And an odd function, f of negative x equals negative f of x. And essentially, that allows us, in the case of an even function, you can just drop the negative inside the function. In the case of an odd function, you can pull the negative out. So it allows us to get rid of negatives inside of our trig functions, assuming they're even or odd. And in this case, and again, when you get to the graphing, it's easier to see. Secant is a reciprocal of cosine. Cosine is an even function, which means f of x equals f of negative x. Or, put another way, cosine of negative x equals cosine of x. You can just drop the negative sign. But since secant is the reciprocal of cosine, it has the same properties, and secant of negative t is secant of t. So then I get secant of t minus secant of t, which is just 0, and I'm done. The second one, number 72. We have cotangent of negative 3t minus 3 cotangent of 3t plus pi. And we're essentially going to use the same two ideas here, the periodicity and the even or oddness. In this case, sine, cosine, secant, and cosecant all have period 2 pi. Tangent and cotangent are the different ones. They have period pi, which means cotangent of 3t plus pi is the same, we can just rewrite this, is negative 3 cotangent of 3t. We can just drop the pi. But now, as it turns out, cotangent and tangent are both odd functions, which means this negative right here, I can pull to the front. It doesn't disappear like it does for an even function. I just pull it to the front. So I get negative cotangent 3t minus 3 cotangent 3t. Now these are like terms, I can combine them. Negative 1 minus 3 is negative 4 cotangent 3t, and we're done. While this trigonometry stuff is very graphical in nature, and we've graphed things, units, circle, right triangles, SOHCAHTOA, and ultimately we will graph these functions and that'll give us a better idea of their properties. We also want to do a lot of algebra with these things, which is why, like I said, I gave you these problems to mess around with. Okay, and then the other problem, page 495, number 70. So, an airplane traveling 400 miles per hour at a cruising altitude of 6.6 miles. So I have an airplane. It's at a cruising altitude of 6.6 miles. Begins its descent. The angle of descent is 2 degrees from the horizontal, which we know means I can draw a triangle like this. Angle of descent is this angle, which is 2 degrees, but we understand alternate interior angles with parallel lines. That also makes this angle 2 degrees. Determine the altitude after 15 minutes round to the nearest tenth of a mile. And I'm told that I'm flying at 400 miles per hour. And then I want to know after 15 minutes. And I want to know the new altitude after 15 minutes. So essentially we understand, I'm going to fly down this angle right here, and then ultimately I'm going to end up with a smaller triangle right here. This will still be 2 degrees. I want to find this height right here, which means I just need a little bit more information. But, well, let's see. I'm traveling at 400 miles per hour. After 15 minutes, that means I go 100 miles. Because 400 miles per hour, 15 minutes is a quarter of an hour, so 100 miles. And now this one I'm actually not going to solve out because I want you people to do the solving out. But at least the setup, I did this in my seated class too because they're the same questions. I have this and I have this. Can I get this right here? Well, yeah, I actually probably can. SOHCAHTOA. So let's see, if this is opposite and this is hypotenuse, then I get sine. So sine of 2 degrees equals opposite, which is 6.6, over hypotenuse, which I'll call h. Solve this out algebraically, multiply the h, then divide the sine. H equals 6.6 over sine of 2 degrees. I do not know that side right there, but for the sake of argument, I'm just going to say the length of this side is 500. It's not, I'm making that up. But suppose when I plug that in, that's what I get. Well then, I know if this is 500, then after 15 minutes, I'm going to be 100 miles closer, which would then tell me that over here in my smaller triangle, that's 400 miles. Again, making this up. Now, I want to find this x, but I can actually set up the same thing. Sine of 2 degrees equals opposite x over 400. And then I get x equals 400 sine of 2 degrees. And again, those numbers are off, I'm just making them up. I want you people to work through it. But here, there is an idea here for a lot of this stuff. It involves triangles, and right triangles for the most part. Later on, we'll do other triangles. Which means you just have to draw a lot of triangles. Sometimes you end up drawing more than one. And you end up, say, using your SOHCAHTOA more than once. But ultimately, it's just the same trick. It's not new tricks that you have to learn. It's the same SOHCAHTOA trick done over and over and over again because they're right triangles. Maybe you'll throw in a Pythagorean theorem or something like that, but essentially the same thing over and over and over. If there are any other questions about homework, feel free to email me, let me know. Do not just write it on your homework when you upload your homework and draw a question mark or say, I don't understand this. Email me and say, hey, I had trouble with number 18 on 4.4. Could you please go through it? And I'll either explain by way of email, or there's a good bet if you have a question, so your classmates, and then I'll just do this again and make a video running through the solutions so you can see them worked out.